Hi everyone, this is Darren here, and today I was thinking that maybe some of you are having troubles with using identities in algebraic manipulation. So I thought I show you an exercise that I give some of my students to do where they can actually practice using the identities simply with simpler numbers rather than, it's not a complicated way, it's a easy and a fun exercise to do, okay? So please follow along, and when I write the question down, maybe you try to get the answer before I present to you the answer, so that way you can actually know whether you're using your identities correctly. Okay, without further ado, here's my first example. Say we had 201 square. We have to solve this, okay? So all the questions here, I'm going to give a number, but I'm not going to use a calculator to solve. I'm going to use the algebraic identities to solve. So let's say we are faced with 201 square, okay? What do we do? You see, what we have to realize is that 201 square can also be broken down into this. Okay? So this is really the key. When I break 201 down into 201, because I'm choosing nice whole numbers, right? So 200 is a nice one, and 1 of course is easy. So now I break it down to 201 into two numbers and then a square. So now see, suddenly from this number we have gone to an identity actually. And this identity is, yes, it is a plus b square, actually is in the same form. So therefore we know that a plus b square is equals to a square plus 2ab plus b square. Hence, what do we get? This will just give me a square, right? So we now know that this is our a and this is our b. So therefore we'll get 200 square plus 2ab. So plus 2ab and then plus b square. So b square is just 1 square, right? So then I'll write it like this. Later on I'll simplify it. So this will give me 40,000, because 200 times 200. So 40,000 plus 400. 200 times 2 and then times 1, just still 400, and this just will be plus 1. Hence this will just be 40401. Okay, so this is the final answer. Okay, let me move on. Another example. Okay, say we had what, let's have a bigger number, okay? Maybe you see whether the identities really actually still apply even if the numbers are big. So let's say now this was 1005 square. Well, the identities still apply, of course actually will still apply, but okay, just let me do this now. Recall that identities actually apply for anything as long as the pattern is the same. So again, I'm going to break this down. See, this is very similar to 201 square. I can just break this down to 1000 and plus 5 square, right? Yes. So now again, now our 1000 is our A and now 5 is our B. Hence we get A square plus 2ab plus b square. So A square is 1000 square plus 2ab plus b square. So 5 square, right? So that's 25 actually. Okay, so now I'll simplify this. 1000 times 1000 giving us 1 million. And this will give me 2000. 2 times 1000, 2000. Times 5, 10,000. So hence this will be 10,000. And this will just be 25. So our answer in this case will be, yes, it's a very big number, but okay, just this to show you that don't be deterred. Identity still can work. So even if you have to do this without a calculator, you could use the identities to really help you still, as you can see. So this is going to give us 101025. So this is the final answer. Okay, so now let me move on to something else. Slightly more tricky now. Okay. So let's say 999 square. And I'm not using a calculator to solve this, so okay, actually when I see this straight away, I can realize, maybe I want to do 900 plus 99 square. Okay, this, yes, you are right. You can use this identity. It is fine. But actually, this is still quite difficult even without a calculator. Simpler would be, how if I break down 99 into 1000 minus 1 square instead, right? See? Yes! So this is the trick. So identities, yes, you can actually use a few identities to solve this, but you have to try to think about what is the easiest one we want to use. Which is the easiest one? So in this case, I usually use the a minus b square one. It's easier because I'm going to deal with 1001, which are of course easier than 999. Right? If I do 900 plus 99, it's more difficult than 1000 minus 1. So now this gives me, I'm going to use the a minus b square identity. So we know that gives us a square minus 2ab minus b square. So this is now a square. Again, this is just going to be our 1 million minus 2ab, so minus 2, 1000, 1, and then plus b square. So this is just, our b is just 1, right? So plus 1 square. Hence, now just simplify this, will give us 1 million, and this will give us 2000 minus 2000, and this will be plus 1. Okay, and then we go about solving this. So this just gives us, okay, this is also slightly complicated, so let me just use some workings here. So I'm going to put 1 million and 1, right, minus 2000. So here I'll cancel and get 9, 9, 9. Okay, and so now this gives us, no, sorry, 10 here. Okay, so now it becomes 1, 0, 0, 8, 9, 9, right? Okay, so I have calculated this. So yes, still without a calculator. Maybe I faced a bit of difficulties, but definitely doable without a calculator still. I think if I had to use this without a calculator and without this identities, it'll be even much more of a hassle. So you see, actually, these identities are helping me still. So now the answer is just 998001. Okay, so this is our final answer. Okay, so let's move on. For example now, let's say we want to use the last identity. And what's the last identity? Do you recall it? Okay, yes, our last identity is a plus b times a minus b equals to a square minus b square. So now let's see, what are some numbers we can use that are similar to this pattern? Okay, so let's say we have 102 times 98. Hey, this is not really that similar, is it? So was I trying to trick you? No, I wasn't, okay? This is actually still correct, but let me show you how I can make this into a minus b, a plus b format. So the trick is that if I do 100 plus 2 and 100 minus 2, you see? Isn't this brackets becoming, if I do this, because brackets means you have to add this 2 up first, right? Before you multiply with this 2, and this 2 you also have to add this 2 up first, and this times this. So this actually gives me 102, I can break it down to 100 plus 2, and 98 I can break down to 100 minus 2. Therefore, I use this same identity and I know it's going to be a square minus b square. Therefore, this is just 100 square minus 2 square. So this is 10,000 minus 4, giving me 9996. Okay? So really quickly, I'm actually able to solve this kind of difficult maths problems without the help of our useful formulas, the useful identities. Okay? So now, just a final question, a last one. Bigger numbers this time, and 495 times 505. Are you able to tell which identity will be and how we'll break it down to? I hope so by now. This is our fifth example, so maybe you want to pause the video and think, or if you are not able, maybe you have to watch, maybe please watch this video again. Okay, but most of you, I believe, are able. Okay, so let me just finish off this last example and end the video. So what happens is that this is just going to be 500 minus 5 and 500 plus 5. Yes? Yeah. You see, this is actually very similar to the fourth example. That was just 100 and 2, and now here we have 505. That is our A and B. So therefore, this gives me, so we know that 500 is our A, and B is our, and 5 is our B. So therefore, this is going to be, using this identity, it's A minus B, A plus B, right? So we'll get 500 square minus 5 square. So this is just 25,000. Okay, and then this is going to be minus 25. Okay, sorry, this is going to be more than that actually. This is going to be 250,000. So I'm going to minus 25 from his. And what do we get? So we just get, we do some calculation again. So 57994. Okay. So therefore this is our answer. This is our final answer. I hope that this video really helped you to help you understand the identities better, and have you realized that identities can be used for a wide array of things, like not just algebraic numbers, but also even when you're using multiplication of just normal numbers. So please remember your identities and know that it can help you in your exams. So I hope that you enjoyed this video, and as always, please like and subscribe. Thank you very much.